The year was 1940, and Britain stood on the edge of exhaustion. After Dunkirk, the British Army had been evacuated but stripped of much of its heavy equipment. The Luftwaffe rained destruction across London, Coventry, and the industrial heartlands, leaving the island nation teetering between resilience and despair. In basements and bomb shelters, ordinary citizens clung to a fragile hope, while military planners grappled with a grim reality. Britain alone could not match Germany's industrial and technological might. Every aircraft lost, every tank abandoned, every convoy sunk highlighted the gaping holes in production capacity and innovation. British engineers and scientists had demonstrated ingenuity, but their reach was constrained by the limits of manpower, materials, and time. Radar was proving vital, yet Britain lacked the factories to mass-produce the equipment at the scale needed to fully defend its skies. Anti-submarine warfare relied on makeshift methods and the limited number of escort vessels. Each day, the U-boat menace tightened its grip on the Atlantic, threatening the lifelines of food, fuel, and raw materials. Britain could innovate, but it could not industrialize rapidly enough to meet the relentless German machine. Across the Atlantic, the United States watched with a mixture of apprehension and strategic calculation. Though officially neutral, Washington recognized that the fate of Britain would shape the entire war. American industry, vast, untapped, and brimming with potential, represented a reservoir of power that could tip the balance. The Ford assembly lines, the DuPont chemical plants, and the sprawling steel mills of Pittsburgh held capabilities that far outstripped anything on the British Isles. What Britain could imagine, America could mass-produce, often in weeks rather than months. The challenge was to channel that enormous industrial potential into solving problems Britain could not. In laboratories from Boston to California, American scientists began to translate theoretical advances into practical wartime tools. They refined sonar technology to track submarines across the Atlantic, developed improved aircraft engines that could sustain longer patrols, and designed modular tanks that could be adapted to multiple theaters of war. This was not just production. It was a revolution in problem-solving. Where Britain's solutions were constrained by scarcity and urgency, America could iterate, test, and deliver innovation on an unprecedented scale. The first tangible fruits of this collaboration came in the form of the Lend-Lease program. Through it, American innovation was no longer hypothetical. It became material, flowing into Britain's hands. Trucks, tanks, airplanes, and ammunition arrived in quantities that could sustain and even expand the beleaguered British war effort. But beyond hardware, it was the infusion of new design philosophies, production techniques, and logistical thinking that transformed the battlefield. Britain was receiving not just tools, but a blueprint for solving problems it could not confront alone. Shipyards in Massachusetts and California began turning out Liberty ships at a pace that defied imagination. Each vessel was designed to be simple, fast to build, and capable of crossing the treacherous Atlantic loaded with essential cargo. Britain's shipyards had been destroyed or overwhelmed, leaving convoys vulnerable. The American answer was industrial ingenuity. Welds instead of rivets, prefabricated sections, and standardized engines allowed hundreds of ships to be launched in months. Each new vessel became a lifeline, and with every successful crossing, the strategic horizon shifted in favor of the Allies. American laboratories also addressed the limitations of British ordnance. Anti-aircraft guns, mortars, and artillery pieces were redesigned for greater efficiency and mass production. The United States experimented with new alloys, propellants, and guidance systems, accelerating technological solutions that Britain lacked the resources to implement on its own. By the time German bombers reigned over London in 1941, many of the anti-aircraft systems in place were either direct products of American research or adaptations facilitated by American mass production techniques. The psychological impact of American innovation cannot be understated. For the British public, seeing trucks and tanks rolling off American ships, fully equipped and battle-ready, offered more than material support. It inspired hope. Soldiers trained on American-produced gear, engineers adopted American modular techniques, and commanders began to plan operations with the confidence that supply shortages would no longer dictate strategy. In essence, American innovation solved a problem that was as much about morale and confidence as it was about hardware. The the belief that Britain could endure, fight, and eventually win. While Britain's engineers had pushed the boundaries of radar, sonar, and cryptography, the United States transformed these concepts into scalable solutions. American research teams developed advanced magnetron tubes for radar, dramatically increasing detection range and resolution. Factories in New Jersey and Ohio were soon producing these tubes by the tens of thousands, enabling both the Royal Air Force and the U.S. Army Air Forces to detect enemy aircraft and submarines before they struck. Britain had the concept, but America had the capacity to make it ubiquitous, turning technological advantage into tactical inevitability. In aviation, the contrast was even starker. British Spitfires and Hurricanes had proven their mettle in the Battle of Britain, but numbers were finite, and engine production could not keep pace with attrition. American factories, unburdened by active combat zones, produced bombers, fighters, and transport aircraft at a staggering scale. The B-17 Flying Fortress and later the B-24 Liberator were not just weapons. They were solutions to a logistical and strategic dilemma Britain could not fully solve, maintaining sustained air pressure on the Axis while protecting vital supply lines. These aircraft, delivered through Lend-Lease, allowed Britain to extend its reach, project power, and gain breathing space for rebuilding its economy and military. Naval warfare presented another arena where American innovation reshaped British strategy. The Battle of the Atlantic had seen U-boats sink countless merchant ships, threatening starvation and industrial paralysis. American shipyards not only built escort vessels, but introduced sonar-guided depth charges and innovative convoy systems. Radar-equipped destroyers, anti-submarine blimps, and long-range aircraft, all products of American ingenuity, transformed the Atlantic from a graveyard of convoys into a contested, survivable corridor. Britain could plan with American technology as a shield, rather than merely hope for luck or German mistakes. Beyond hardware, American innovation revolutionized production methodology itself. Techniques like assembly line tank construction, modular aircraft assembly, and prefabricated shipbuilding allowed Britain to bypass its industrial bottlenecks. Where British engineers were constrained by workshop capacities and skilled labor shortages, American factories leveraged mass production, standardized parts, and industrial engineering principles to flood theaters of war with reliable machinery. These methods did more than increase numbers. They ensured uniformity, simplified maintenance, and allowed British forces to operate more efficiently with fewer skilled mechanics. The chemical sciences offered another frontier of collaboration. Britain's munitions and explosives were limited by resource scarcity and the pressures of ongoing air raids. American chemical plants, producing everything from high-grade TNT to synthetic rubber and aviation fuel, provided the raw materials necessary to sustain prolonged conflict. Innovations in lubricants, antifreeze, and corrosion-resistant coatings extended the lifespan of British vehicles and artillery, solving practical problems that had previously hampered operational readiness. Each innovation, while seemingly technical, had immediate battlefield consequences. Guns fired longer, engines ran smoother, and supply convoys survived treacherous seas. American innovation also extended into intelligence and communications. British codebreakers had cracked Enigma, but transmitting insights across the Atlantic and coordinating multinational fleets remained a challenge. American engineers developed long-range radios, encryption devices, and high-frequency radio direction-finding equipment that allowed intelligence to flow faster than enemy interception. The result was an integrated system where British brilliance and American capability merged. Decoded intelligence reached commanders in time to act decisively, turning foresight into concrete operational advantage. Human ingenuity intertwined with industrial scale in medicine and field care as well. Britain struggled to keep up with medical supplies, antibiotics, and surgical tools for its wounded soldiers. American pharmaceutical companies mass-produced penicillin, morphine, and other critical medications, while portable medical kits and field hospitals, designed for rapid deployment, ensured that casualties survived where previously they would have perished. Innovation solved not just mechanical problems, but human ones, sustaining the very lives needed to keep armies in the field. The cumulative effect of American innovation on Britain was profound. It was not simply that more tanks or planes arrived. It was that the British military could now operate strategically rather than reactively. Constraints that once dictated decisions, material shortages, industrial incapacity, limited technological reach, were lifted. American ingenuity became the silent partner behind every British operation, allowing the island nation to punch above its weight and set the stage for a global offensive that would eventually roll back the Axis on multiple fronts. Industrial collaboration was mirrored in the realm of experimental technology. Britain had explored jet propulsion and rocket science, but wartime urgency left research incomplete. American engineers accelerated these concepts, creating practical jet engines, guided bombs, and early rocket-assisted artillery. Factories in the Midwest could produce experimental designs in volumes unthinkable in Britain, effectively bridging the gap between theory and battlefield application. By 1944, Allied forces were benefiting from weapons whose roots lay in British ingenuity, but whose realization depended entirely on American execution. Tank warfare illustrated this synergy vividly. Britain's Matilda and Churchill tanks had been armored and reliable, but slow and undergunned. The United States designed the Sherman, a medium tank optimized for mass production, versatility, and ease of repair. British crews trained on Shermans in Egypt and Italy, appreciating not just their firepower, but their modularity. Spare parts, engines, and even entire hulls could be swapped efficiently, a direct answer to the logistical nightmare Britain had faced with heterogeneous tank fleets. Innovation met practical necessity, enabling mobility and sustained offensive capability across multiple theaters. Aircraft carriers and naval aviation also bore the imprint of American ingenuity. Britain's carrier fleet had been limited and vulnerable, especially in the Mediterranean and Pacific theaters. American shipbuilding produced Essex-class carriers capable of supporting hundreds of aircraft, while innovations in radar, catapult launch systems, and coordinated fleet operations expanded operational reach. British admirals could now project power far beyond home waters, secure supply routes, and assist in joint operations that were previously beyond the Royal Navy's logistical limits. The war's Arctic convoys presented another extreme challenge, as British ships struggled to deliver supplies to the Soviet Union across frozen seas patrolled by German U-boats and aircraft. American ice-strengthened Liberty ships, equipped with advanced navigation and communications systems, dramatically increased the success rate of these perilous missions. Crews braved gale-force winds, sub-zero temperatures, and relentless enemy attacks, relying on innovations, from hull design to radar-assisted detection, that Britain alone could not have produced at scale. Each safe arrival reinforced the fragile alliance on the Eastern Front, contributing to the eventual collapse of Nazi Germany. Innovation also extended to training and doctrine. British instructors adopted American-produced flight simulators, gunnery trainers, and armored vehicle mock-ups, allowing personnel to master complex systems before entering combat. This minimized losses and accelerated operational readiness. Where British forces had previously been forced into trial by fire, they now benefited from systematic, reproducible preparation. American solutions addressed the human dimension of warfare, not just machines, but the men and women who operated them. The influence of American logistics and innovation reached deep into strategic planning. With material shortages alleviated, British generals could devise operations unconstrained by limited firepower or transport. Operation Torch in North Africa, for instance, relied heavily on American shipping, armored divisions, and air support. Where previously British offensives had faltered for lack of sustained supplies or equipment, now they could coordinate complex multinational maneuvers with confidence. Innovation, in this sense, solved not abstract problems, but the concrete challenges of projecting force across continents. Even the home front was transformed. American innovations in portable generators, communications equipment, and prefabricated shelters allowed British industry and military installations to maintain production and readiness despite bombing raids. Factories could restart rapidly after air attacks, hospitals could operate efficiently, and civil defense networks could function under stress. In every case, American ingenuity solved bottlenecks that Britain's exhausted workforce and infrastructure could not address alone, sustaining both morale and material capacity. Ultimately, The story of American innovation in Britain's war effort was one of interdependence. Britain provided vision, daring, and experience born of early struggle. America provided scale, speed, and technical mastery capable of transforming that vision into reality. Together, they overcame the challenges that Britain alone could not, turning despair into capability and desperation into decisive action. The seeds planted by this collaboration would not only carry the Allies to victory, but redefine the relationship between innovation, industrial power, and modern warfare. As the war progressed into 1942, the limitations that had once constricted Britain became increasingly apparent, particularly in mechanized warfare and long-range operations. British factories were exhausted, skilled labor was stretched to the breaking point, and raw materials had to be rationed between competing military priorities. While Britain's engineers had conceived solutions, the pace of destruction and attrition made implementation painfully slow. Across the Atlantic, American industrial complexes, free from the immediate threat of bombing and invasion, could transform theoretical concepts into operational reality with astonishing speed. The contrast was stark. While Britain struggled to maintain production lines and keep its tanks operational, America was experimenting with modular assembly techniques, mass-producing aircraft and naval vessels, and delivering sophisticated weaponry to the front lines in a matter of weeks. This industrial might did not merely supply Britain. It redefined the strategic horizon, allowing commanders to contemplate offensives they had once considered impossible due to material constraints. The Battle of the Atlantic exemplified the symbiosis of British ingenuity and American scale. British sonar technology and cryptography provided the tactical know-how to anticipate U-boat movements, but the sheer number of escort ships, long-range aircraft, and convoy vessels necessary to implement these strategies exceeded Britain's capacity. American shipyards responded with a flood of Liberty ships, destroyer escorts, and anti-submarine vessels, incorporating technological improvements in hull design, sonar, and radar that maximized survivability in hostile waters. Each vessel arriving in Liverpool or Scapa Flow was more than a replacement. It was an exponential multiplier of strategic options, allowing convoys to sail in tighter formations, deploy layered defenses, and gradually push back the German submarine threat. For sailors in the North Atlantic, where freezing spray, enemy torpedoes, and relentless storm winds were constant companions, American innovation represented the tangible difference between survival and disaster. In aviation, the infusion of American technology and production solved problems Britain could not meet alone. The Spitfire and Hurricane had won the Battle of Britain, but the Luftwaffe's persistent pressure demanded a more robust response across multiple theaters. American production lines turned out thousands of P-51 Mustangs and B-17 Flying Fortresses, integrating advanced engine designs, extended range, and high-altitude performance that enabled the Allies to conduct strategic bombing campaigns over Germany while maintaining air superiority. British pilots trained on these aircraft found themselves with machines that were not just superior in numbers, but also in reliability, maintainability, and adaptability. The integration of American engines, avionics, and airframes into British operations exemplified a new paradigm. Where Britain could innovate tactically, America could provide the tools to scale that innovation into a decisive strategic advantage. The story of armored warfare was equally transformative. British tanks had been effective in specific scenarios but often suffered from limited mobility, inadequate firepower, or logistical fragility. American tank design emphasized mass production, standardization, and modularity, producing vehicles that could operate in diverse environments, from the deserts of North Africa to the hedgerows of Normandy. Spare parts, interchangeable components, and simplified repair procedures meant that damaged tanks could be returned to service in days rather than weeks. British commanders, previously constrained by attrition and maintenance bottlenecks, could now plan sustained offensives, confident that their armored divisions would remain operational. This mechanized revolution extended far beyond hardware. It transformed battlefield psychology, enabling soldiers and officers alike to approach combat with an unprecedented level of confidence in their resources and mobility. Chemical and material sciences became another arena where American innovation filled critical gaps. Britain had long relied on limited domestic production of explosives, fuels, and synthetic materials, but American factories produced vast quantities of high-octane aviation fuel, synthetic rubber, advanced lubricants, and corrosion-resistant metals. These materials were vital for keeping vehicles running in extreme environments, maintaining the operational integrity of aircraft engines under combat stress, and ensuring the durability of artillery under repeated use. Beyond raw production, American engineers innovated an application: lubricants that performed in Arctic cold, antifreeze compounds that allowed tanks to operate in the desert, and coatings that extended the lifespan of naval vessels in corrosive waters. Each of these innovations solved concrete problems that Britain had struggled to overcome, often under the duress of relentless bombing and material scarcity. American contribution extended into medical science and battlefield medicine in ways that directly affected survival rates. The mass production of penicillin, surgical kits, and field-ready medical equipment revolutionized casualty treatment. British hospitals and field medics, previously constrained by ration supplies and limited pharmaceuticals, suddenly had access to life-saving treatments in sufficient quantities to handle large-scale operations. Wounded soldiers who might have perished from infection or delayed care were now stabilized and returned to duty, preserving manpower that was critical for sustaining prolonged campaigns. The human cost of innovation became tangible, as each scientific breakthrough directly saved lives and enabled operational continuity in ways that pure strategic planning alone could not achieve. Logistics, often invisible but decisive, was another domain transformed by American industrial power. Britain faced chronic shortages in transport vehicles, fuel storage, and ammunition supply chains. American trucks, jeeps, and fuel tankers arrived in massive numbers, enabling the rapid movement of troops, artillery, and essential supplies across continents. Military planners could finally coordinate complex operations, confident that material flow would not be the limiting factor. In North Africa, Italy, and later in Europe, these logistical solutions directly facilitated major offensives, turning strategic ambition into operational reality. The lesson was clear. Innovation was not just about creating advanced technology, but ensuring that it could be delivered, maintained, and deployed at scale. The psychological dimension of American assistance was profound. For British soldiers, engineers, and civilians alike, the arrival of American-built tanks, aircraft, ships, and supplies was a tangible sign that their struggle was not isolated. Hope, previously precarious, became a durable foundation upon which strategy, morale, and initiative could be built. The infusion of American ingenuity, in both material and methodology, transformed Britain's perception of the war from a fight for survival to a coordinated, achievable campaign. In essence, the combination of British vision and American capacity created a synergy that solved not only practical and technological problems, but also the most elusive challenge in war: sustaining belief in ultimate victory. The synergy between British vision and American industrial capability became particularly visible in the development and deployment of radar and early warning systems. Britain had pioneered radar technology, creating an early warning network that had been crucial in the Battle of Britain, yet scaling and maintaining these systems had been a perpetual challenge. American manufacturers, drawing on vast resources and standardized production methods, produced radar units, magnetrons, and associated electronics in quantities that far outstripped British capacity. The result was a network capable of monitoring the skies and seas across multiple theaters, providing commanders with actionable intelligence, and giving Allied forces the precious gift of time to deploy interceptors, reposition convoys, and anticipate enemy maneuvers. American innovation, in this case, transformed brilliance into operational ubiquity, allowing technological advantage to translate directly into strategic leverage. Aircraft production remained one of the most dramatic illustrations of this transatlantic collaboration. Britain's aircraft industry had been severely strained by bombings and attrition, and each lost plane was a tactical crisis. American factories, however, were unimpeded by enemy attacks and capable of producing thousands of aircraft per month. Models such as the P-51 Mustang, P-38 Lightning, and B-24 Liberator were delivered in unprecedented numbers, providing Britain with not just replacement airframes, but platforms superior in range, speed, and payload to most Axis counterparts. This infusion of material not only allowed sustained defensive operations, but enabled the Allies to launch offensive campaigns over Europe with confidence, striking at industrial centers, supply lines, and communication hubs that Britain alone could never have reached with limited numbers. Naval innovation similarly highlighted the American contribution. British convoys had been under constant threat from German U-boats, with losses mounting despite tactical ingenuity and intelligence breakthroughs. American engineers developed long-range anti-submarine aircraft, sonar-equipped destroyers, and modular escort vessels that could be produced quickly and deployed across global theaters. These innovations enabled more robust convoy defenses, more effective U-boat hunting, and a reduction in shipping losses that had once threatened to strangle the British war economy. Each successful convoy crossing became a testament to the combination of British strategic planning and American problem-solving, demonstrating how industrial capacity could convert clever tactics into sustained operational success. In armored warfare, American innovation addressed one of Britain's most persistent challenges, the need for standardized, reparable, and versatile tanks. The Sherman tank exemplified this solution. Its design emphasized modular construction, ease of repair, and adaptability across terrains, from the deserts of North Africa to the forests of Europe. Spare parts were standardized, engines were interchangeable, and field repairs could be performed under combat conditions with minimal delay. British crews, trained in desert warfare and urban combat, quickly recognized the tactical and logistical advantages of these vehicles, which allowed them to mount sustained offensives without the constant interruption of maintenance crises that had hampered earlier operations. The Sherman was more than a tank. It was a practical solution to the intertwined challenges of mobility, firepower, and sustainment. Chemical and materials engineering provided another layer of critical support. Britain's limited access to synthetic rubber, high-octane fuel, and industrial chemicals constrained operational planning and equipment reliability. American production of these materials at scale solved a series of cascading problems. Vehicles ran longer without breakdowns, aircraft engines maintained performance under extreme conditions, and naval vessels resisted corrosion during long deployments. These innovations were not abstract. They had immediate consequences in theater. Armies moved faster, fleets stayed operational longer, and air campaigns could be conducted over extended ranges, all because the material limitations that had previously dictated strategy were now addressed through American ingenuity. The human dimension of these innovations was equally significant. American production of medical supplies, including penicillin, field surgical kits, and portable equipment, directly improved survival rates for wounded soldiers. British medics, previously hampered by scarcity, could now treat injuries quickly and effectively, ensuring that manpower losses did not cripple ongoing operations. Soldiers' morale improved as they realized that their survival, maintenance, and operational readiness were backed by a reliable supply chain, a critical psychological factor that often determined the outcome of engagements as much as firepower or strategy. Training and doctrine benefited as well from American contributions. British forces had been forced to improvise in training due to equipment shortages, but American simulators, gunnery trainers, and armored vehicle mock-ups allowed for realistic, high-intensity preparation. Soldiers and crews could learn procedures in controlled environments, reducing casualties and improving effectiveness when confronted by Axis forces. This integration of technological innovation with human training was a direct answer to Britain's earlier dilemma: how to maintain combat readiness when resources were constrained. Ultimately, by 1943, the combined effect of American innovation and British strategy had begun to reshape the global conflict. Britain was no longer on the defensive alone. It could project force, sustain operations, and coordinate multi-theater campaigns. Where once British planners had been limited by industrial capacity, logistical shortages, and technological bottlenecks, they now benefited from a transatlantic industrial partnership capable of solving problems on a massive scale. The war was still far from won, but the combination of ingenuity, production, and strategic coordination had begun to tilt the scales decisively in favor of the Allies. The North African campaign illustrates the profound effect of American innovation on operational outcomes. Britain had initially struggled to contain Axis forces in the desert, hampered by insufficient transport vehicles, tanks, and artillery capable of surviving the harsh environment. American trucks, jeeps, and logistical equipment enabled the rapid movement of troops and supplies, overcoming terrain that had previously frustrated strategic planning. Modular Sherman tanks and American-designed artillery pieces could be repaired in the field, keeping combat units operational over extended campaigns. The Desert War, previously a stalemate dictated by material scarcity, became a theater where British strategy could be executed decisively, with American production ensuring that equipment, fuel, and spare parts never fell short. Air superiority in the Mediterranean was similarly transformed. British aircraft were limited in range and numbers, forcing reliance on defensive operations and sporadic attacks. American long-range bombers and fighter escorts provided the Allies with the capacity to conduct sustained campaigns against Axis supply lines, ports, and fortifications. The ability to strike deeply into enemy territory not only disrupted operations, but also allowed British and Allied commanders to plan joint offensives, confident that air support would be available when and where it was most needed. American innovation, in this context, solved both strategic and operational problems, extending Britain's reach far beyond what it could achieve alone. In logistics, the United States revolutionized supply chain management for the British war effort. Standardized shipping containers, prefabricated docks, and modular storage facilities allowed rapid unloading and distribution of materials. Britain, previously constrained by port capacity and labor shortages, could now receive and deploy equipment with unprecedented efficiency. In the chaos of wartime operations, these innovations turned potential bottlenecks into smooth conduits of material, enabling coordinated offensives that had previously been limited by logistical uncertainty. Each shipment arriving on time represented not just material support, but the resolution of strategic dilemmas that had once constrained British operational planning. Naval engagements also benefited from American design and mass production. Escort carriers, sonar-equipped destroyers, and anti-submarine warfare aircraft produced in the United States provided the Royal Navy with the tools to protect convoys and project power. British ships, once vulnerable to U-boat ambushes, could now operate within integrated defensive networks supported by radar, sonar, and aerial reconnaissance. Each successful engagement reduced losses, preserved essential supplies, and reinforced the psychological resilience of crews who understood that innovation and production had mitigated risks previously deemed insurmountable. The human cost of innovation was most visible in field medicine. American production of antibiotics, surgical instruments, and portable medical units meant that injuries which once would have been fatal were now survivable. Field hospitals could operate efficiently even in forward positions, and soldiers could return to combat in greater numbers and with higher morale. British and Allied forces could sustain prolonged campaigns without facing the crippling manpower shortages that had plagued earlier operations. American innovation had, in effect, solved the problem of survival under extreme wartime stress, ensuring that material and human resources were synchronized in support of strategic objectives. Chemical engineering played a pivotal role in maintaining operational readiness. Aviation fuels, synthetic rubber, and lubricants produced in American plants enabled tanks, trucks, and aircraft to perform reliably in desert heat, Arctic cold, and European rain. Previously, extreme environmental conditions had imposed significant limits on British operational planning, forcing commanders to constrain maneuvers to what equipment could endure. With American-produced materials, these environmental constraints were dramatically reduced, providing tactical flexibility and strategic options that Britain had once only imagined. The integration of American innovation also extended to intelligence and communications. British cryptographers and codebreakers had developed unprecedented capabilities, but translating intelligence into action required reliable communication systems. American-produced radios, encryption devices, and direction-finding equipment allowed intelligence to reach field commanders quickly, securely, and reliably. This integration ensured that British strategic foresight could be executed in real time, with minimal delays or miscommunication. Innovation, in this context, solved not a single problem, but a chain of challenges spanning perception, planning, and execution. By mid-1943, the cumulative effect of American innovation across technology, logistics, medicine, and materials had transformed Britain's role in the war. No longer constrained by shortages or limited production capacity, British forces could operate with confidence, sustain prolonged campaigns, and coordinate multi-theater strategies. The transatlantic partnership had evolved into a mechanism by which theoretical British solutions could be realized at scale, enabling victories in North Africa, Italy, and eventually across Western Europe. In every sense, American innovation solved the problems Britain could not, reshaping not only the course of the war, but the very nature of modern military strategy. The invasion of Italy in 1943 revealed just how critical American industrial ingenuity had become in sustaining British and Allied operations. The mountainous terrain, unpredictable weather, and entrenched German defenses presented a logistical nightmare that Britain alone could not overcome. Roads were limited, bridges had been destroyed, and local supply lines were inadequate for sustained offensive operations. American trucks, jeeps, and portable bridging equipment transformed this landscape from a strategic obstacle into a manageable operational theater. Convoys could move artillery, fuel, and provisions across steep inclines and narrow passes, while Sherman tanks, designed for adaptability, allowed armored divisions to navigate terrain that had previously stymied movement. Every logistical innovation, from prefabricated Bailey bridges to modular supply depots, ensured that British forces could project sustained power in a theater where the environment itself had once been a formidable adversary. Air power in Italy further highlighted the synergy of British strategy and American production. The Allies required long-range bombers capable of reaching deep into Axis territory while evading anti-aircraft defenses and fighter patrols. American-built B-17s and B-24s filled this gap, supplemented by radar and navigation systems designed to maximize operational efficiency. British and Commonwealth aircrews trained on these aircraft discovered that the combination of American endurance and payload capacity allowed precision strikes that disrupted German supply lines, communications, and troop concentrations. The psychological effect was profound. German forces, previously confident in their defensive positions, now faced relentless aerial pressure sustained over months, not days. American innovation had translated tactical opportunity into strategic dominance. Naval operations along the Italian coast also demonstrated the transformative impact of American engineering. Amphibious landings required vessels capable of transporting men, tanks, and supplies while withstanding both artillery and mines. American landing craft, designed for modularity and mass production, allowed the Allies to conduct operations such as the Salerno and Anzio landings with unprecedented precision and coordination. Britain had conceptualized amphibious warfare, but producing and deploying the necessary vessels had been beyond its isolated industrial capacity. American innovation provided the material answer, turning daring operational plans into achievable campaigns. The convergence of design, production, and strategy exemplified the transatlantic partnership at its most effective. In armored combat, the evolving battlefields of southern Europe demanded versatility that British tanks alone could not provide. The Sherman, with its modular components, reliable engine, and capacity for field repairs, allowed British and Allied forces to maintain operational tempo even under constant enemy fire. When units encountered heavily fortified positions, American-designed specialized vehicles, flamethrowers, mine-clearing tanks, and amphibious variants enabled tactical breakthroughs that had previously been impossible. These machines did not simply add firepower. They solved operational problems that had constrained British commanders for years, transforming the way ground campaigns were conceived and executed. American innovation extended beyond hardware into the domain of communications and intelligence coordination. The Italian campaign required real-time coordination between air, land, and naval units across rugged terrain. American-produced radios, encryption systems, and portable signal equipment allowed British commanders to synchronize attacks, respond to enemy movements, and coordinate supply deliveries with unprecedented speed. Previously, Delays in communication had often resulted in missed opportunities or costly engagements. With American innovation, British strategic intent could be executed with precision and reliability, effectively solving a problem that had long been intractable. Medical and logistical innovations continued to support these operations. Field hospitals equipped with American-supplied portable surgical kits, antibiotics, and evacuation equipment allowed wounded soldiers to receive prompt treatment even in forward positions. Trucks and modular supply chains enabled ammunition, food, and fuel to reach frontline units despite the difficult terrain and enemy interdiction. In every theater, from the Apennines to the Adriatic coast, the combination of American material solutions and British operational planning ensured that attrition did not halt progress, demonstrating that innovation in logistics and medicine could decisively shape combat effectiveness. The environmental challenges of Italy also underscored the importance of material science. Vehicles and equipment had to endure torrential rains, mud-choked valleys, and mountainous passes. American-produced lubricants, antifreeze, and corrosion-resistant metals allowed machinery to operate reliably where British designs alone had faltered. British commanders could plan operations with confidence, knowing that their equipment could perform under conditions that had previously imposed severe limitations. In this way, American ingenuity solved the practical problems of sustaining combat operations in extreme environments, enabling strategic mobility where it had once been impossible. By the end of 1943, it was evident that the transatlantic alliance of innovation and strategy had fundamentally altered the course of warfare. British vision, tactical brilliance, and frontline experience were amplified by American production, design, and logistical expertise. Problems that had once seemed insurmountable, ranging from material scarcity to extreme terrain, from logistical coordination to equipment reliability, had been resolved through a combination of ingenuity and industrial might. The partnership not only preserved Britain's ability to fight, but transformed it into an engine capable of executing large-scale, coordinated operations on multiple fronts, setting the stage for the eventual liberation of Western Europe. The Normandy invasion of 1944 epitomized the decisive impact of American innovation in solving problems Britain alone could not overcome. Planning for Operation Overlord demanded precise coordination of land, sea, and air forces, along with massive logistical support capable of sustaining a beachhead under constant enemy fire. Britain had the tactical knowledge, the courage, and the experience from previous campaigns, but lacked the industrial capacity to produce the necessary landing craft, tanks, artillery, and supply vehicles in sufficient quantities. American factories, however, had churned out thousands of Sherman tanks, amphibious trucks, and specialized engineering equipment, ensuring that the invasion force would be both numerous and resilient. Each piece of equipment arriving on the beaches represented a tangible solution to strategic and operational dilemmas that had once limited British planning to cautious, incremental offensives. Landing craft, designed for rapid deployment and survivability under fire, exemplified American problem-solving at scale. Britain had experimented with amphibious vehicles and ideas for storming fortified coastlines, but its industrial base could not produce them in the numbers required for D-Day. American innovation not only provided quantity, but introduced modular designs, robust construction, and adaptability to varying beach conditions. Sherman tanks equipped with flamethrowers, mine rollers, and waterproofing capabilities allowed infantry to advance under fire, overcoming obstacles that had once halted entire divisions. The material ingenuity delivered by the United States allowed planners to transform bold concepts into executable operations, solving the twin problems of scale and survivability that had constrained amphibious assaults. Air superiority played a critical role in Normandy, and once again American production proved decisive. Long-range fighters, bombers, and transport aircraft, produced en masse in U.S. factories, enabled sustained aerial bombardment of German positions, close air support for advancing troops, and rapid logistical reinforcement behind the lines. Radar-guided navigation and bombing systems, also supplied by American innovation, allowed precision targeting despite overcast skies and complex terrain. British forces, operating alongside their American allies, benefited from an unprecedented integration of strategy, technology, and sheer industrial capacity, which together ensured that air power could decisively support ground operations, a feat Britain could not have achieved alone. Logistics, often the invisible linchpin of combat success, was transformed through American innovation. Supplying a multinational invasion force required standardized trucks, modular shipping containers, portable bridges, and reliable fuel delivery systems. American engineers had developed methods for rapid unloading of ships, temporary docking solutions, and mobile supply depots capable of functioning under fire. These innovations allowed the Allies to sustain the beachhead despite German counterattacks, ensuring that troops, artillery, and supplies were continuously available. The result was operational continuity in a campaign that might otherwise have faltered due to the sheer scale and complexity of the invasion. Intelligence and communication systems, crucial for coordinating the landings across 5 beachheads, were enhanced by American technology. Radios, signal encryption, and direction-finding equipment produced in the United States allowed real-time coordination between infantry, armor, artillery, and air units. British commanders could issue orders with confidence that they would reach subordinate units promptly and securely, while feedback from the front lines informed tactical adjustments. In effect, American innovation bridged the gap between planning and execution, solving the persistent problem of battlefield communication under extreme conditions. Medical and humanitarian support also reflected the scale of American assistance. Field hospitals supplied with American-produced antibiotics, surgical equipment, and portable units ensured that casualties received prompt and effective treatment, preserving manpower and morale. The ability to evacuate and treat injured soldiers near the front lines allowed commanders to maintain operational strength and minimize attrition. These innovations addressed a practical and human problem that Britain's strained resources could not have solved alone, demonstrating how industrial and medical ingenuity together sustained the fighting force. The combination of technology, production, and innovation also extended to engineering and battlefield mobility. Prefabricated bridges, modular pontoon systems, and bulldozers allowed Allied forces to navigate destroyed infrastructure and minefields, maintaining the momentum of the advance. Sherman tanks, adapted for amphibious landings, and specialized engineering vehicles ensured that operations could continue despite obstacles that had previously immobilized armies. Every challenge imposed by terrain, fortifications, or enemy action was met with a practical solution born of American design and production capacity, solving operational problems that had once constrained British initiative. Ultimately, the success of D-Day highlighted a profound truth. Britain could conceive strategy and fight with courage, but American innovation provided the means to scale, sustain, and operationalize those strategies in ways that were previously impossible. The invasion demonstrated that industrial capacity, technological ingenuity, and logistical planning were as decisive as tactical skill and valor, and that solving problems at scale required not just ideas, but the ability to implement them with relentless efficiency. British brilliance, amplified by American ingenuity, had forged a path through the formidable challenges of Normandy, marking a turning point in the war that would reverberate across Europe. As the Allies advanced through France and into the Low Countries, the reliance on American innovation remained evident in every operational domain. Roads, bridges, and rail networks destroyed by retreating German forces threatened to halt the momentum of advancing divisions. American-engineered modular bridging systems and portable roadways allowed armor, artillery, and supply convoys to traverse these obstacles with minimal delay. British operational plans, which had previously been constrained by infrastructure limitations, could now proceed at a tempo that surprised even the most experienced German commanders. In every sector, the ability to move forces efficiently solved a persistent logistical problem that Britain alone could not have overcome at scale. Air mobility and support continued to showcase the impact of transatlantic ingenuity. American long-range transport aircraft enabled rapid redeployment of troops, while bombers and fighters disrupted enemy lines of communication and supply. British forces could now engage in coordinated multi-pronged offensives with assurance that reinforcements, artillery, and fuel would arrive on schedule. Radar-guided navigation systems, produced in American factories and integrated into Allied air operations, ensured accuracy and operational reliability even in poor weather. Once again, American innovation translated technical advantage into operational success, amplifying the effectiveness of British tactical planning across extended fronts. Armored warfare in Western Europe also benefited from the American approach to mass production and modularity. Sherman tanks and specialized variants provided both firepower and operational flexibility, enabling British and Commonwealth units to respond rapidly to German counterattacks. Field repair and maintenance capabilities, supported by a supply chain of interchangeable parts, minimized downtime and sustained combat effectiveness. Where British tanks had once been limited by production constraints and mechanical reliability, American innovation ensured that armored units could operate continuously, solving a problem that had historically restricted mobility and firepower. Medical support continued to evolve as a result of American contributions. Portable surgical units, field hospitals, and antibiotics supplied by U.S. manufacturers allowed rapid treatment of casualties, maintaining manpower and morale. The ability to evacuate and care for wounded soldiers near the front lines ensured operational continuity and preserved the fighting capability of units engaged in high-intensity combat. In essence, American innovation addressed the human dimension of warfare, solving problems of survival and resilience that directly influenced operational outcomes. The Allies' logistical network across liberated territories exemplified the integration of American innovation with British planning. Modular supply depots, standardized trucks, and portable fuel storage allowed armies to extend their operational reach far beyond previous limitations. British commanders could now plan offensives with confidence, knowing that supplies, artillery, and reinforcements would arrive reliably. In theaters where infrastructure had been destroyed and roads were hazardous, American ingenuity provided practical solutions that turned potential strategic stagnation into forward momentum. Engineering solutions also played a pivotal role in sustaining the Allied advance. Modular pontoon bridges, prefabricated roadways, and specialized engineering vehicles enabled rapid river crossings, overcoming natural and man-made obstacles that had slowed previous campaigns. Sherman tanks equipped with mine-clearing devices and flamethrowers solved battlefield challenges that had historically cost heavy casualties. Each technical solution was a response to a problem that Britain had conceptualized but lacked the capacity to solve alone, demonstrating the indispensable role of American industrial and technological innovation in operational success. The psychological and morale effects of these innovations were profound. British troops, accustomed to shortages and improvisation, now operated with confidence that equipment, supplies, and medical support would be available when needed. This reliability allowed commanders to plan ambitious operations and soldiers to fight with resilience, knowing that their survival and effectiveness were underpinned by a dependable system of support. American innovation, in this sense, solved a problem that was both tangible and intangible: the challenge of sustaining confidence, cohesion, and initiative under the stresses of prolonged warfare. By late 1944, the trajectory of the war had been irrevocably altered by the combination of British strategy and American innovation. Where Britain had once faced the limitations of industrial capacity, logistical constraints, and material scarcity, it now operated within a system where innovation and production flowed seamlessly across the Atlantic. Problems that had previously dictated caution and compromise were now mitigated through ingenuity, scale, and collaboration. The liberation of France and the push into the Low Countries were not solely triumphs of British courage or tactical skill. They were victories enabled by American innovation, which solved the structural and operational challenges that Britain alone could never have overcome. As the Allies crossed the Rhine and pushed deeper into Germany in early 1945, the reliance on American innovation became even more pronounced. British forces had the operational experience, tactical acumen, and intimate knowledge of European terrain, yet the scale of the offensive demanded material, mobility, and coordination that exceeded Britain's industrial capacity. American factories, producing thousands of tanks, trucks, artillery pieces, and ammunition each month, ensured that British divisions could maintain relentless pressure on retreating German formations. Every Sherman tank rolling across the frozen rivers of the Rhineland, every jeep ferrying supplies over devastated roads, represented a solution to logistical and operational challenges that Britain had struggled to overcome alone, turning what might have been a slow attritional campaign into a decisive, rapid advance. The airborne operations that accompanied the push into Germany underscored the scale and sophistication of American support. Britain had pioneered glider operations and paratrooper deployment, but it lacked the aircraft numbers, cargo capacity, and engineering solutions needed for large-scale airborne insertions. American transport planes, including the C-47 Skytran, delivered thousands of troops, vehicles, and supplies behind enemy lines, while innovations in navigation, radio communication, and precision parachuting allowed these operations to be executed with unprecedented efficiency. The combination of British planning and American production solved a problem that had historically restricted airborne capability to small-scale or opportunistic operations, now enabling full-scale strategic maneuvers. Armored mobility across German territory continued to demonstrate the transformative effect of American industrial ingenuity. Sherman tanks, reinforced with improved armor, reliable engines, and modular repair systems, allowed British forces to maintain continuous pressure despite adverse terrain, destroyed infrastructure, and the ever-present threat of counterattacks. Specialized vehicles, such as bridge-laying tanks and mine-clearing variants, provided solutions to natural and man-made obstacles, enabling rapid advances that previously would have required days of engineering effort. American innovation effectively erased the operational limitations imposed by logistics and terrain, allowing Britain to project force decisively into the heart of Germany. Artillery, precision, and firepower were also enhanced by American mass production and technological development. British forces, previously limited by the number and range of available guns, now had access to American-designed howitzers, mortars, and anti-tank artillery capable of delivering sustained, accurate fire. Standardized ammunition, robust supply chains, and modular components meant that artillery units could operate continuously, supporting advances without interruption. Where Britain had once faced the constraint of limited firepower dictating tactical options, American innovation transformed artillery into a reliable and flexible tool of operational dominance. The integration of communications and intelligence systems proved vital in the complex operational environment of late-war Germany. British forces had long relied on encrypted signals, reconnaissance, and local intelligence, but coordination across multinational armies required robust, reliable infrastructure. American-produced radios, signal encryption devices, and direction-finding equipment allowed British commanders to orchestrate multi-front operations, synchronize air and ground assaults, and rapidly react to German maneuvers. This capability solved the persistent problem of real-time coordination over extended theaters of operation, ensuring that strategy could be executed with precision rather than hope. Medical and logistical innovations continued to sustain the British advance. Portable surgical units, field hospitals, and American-supplied antibiotics ensured that wounded soldiers received timely and effective treatment, preserving manpower and morale. Mobile supply convoys, standardized trucks, and modular storage solutions allowed armies to advance without pausing for replenishment. These practical innovations addressed operational and human constraints simultaneously, solving problems that had previously forced pauses or limited operational tempo. The combination of technology, production, and human-centered solutions allowed British forces to fight with resilience, confidence, and efficiency in the war's final, most grueling phase. Engineering solutions, from bridging destroyed rivers to clearing mined roads, relied heavily on American innovation. Prefabricated Bailey bridges, modular road panels, and specialized vehicles enabled rapid reconstruction of infrastructure under fire, ensuring that supply lines remained intact and armored divisions could maintain momentum. Mines, fortifications, and urban rubble, which had previously slowed offensives and caused heavy casualties, were neutralized by equipment conceived and produced in American factories. In every engagement, American engineering provided the tools that allowed British strategic planning to translate into operational success, solving problems that were logistical, mechanical, and tactical all at once. By early 1945, it was clear that the Allied advance into Germany was a victory not just of strategy and courage, but of innovation and production at scale. Britain provided the tactical skill, operational experience, and moral resolve. America provided the industrial capacity, technological ingenuity, and logistical solutions that made sustained, decisive operations possible. Problems that had once constrained British forces, ranging from mobility and firepower to medical care and supply chain management, were systematically addressed through the transatlantic partnership. The liberation of Western Europe and the collapse of German defenses owed as much to the ingenuity and industrial might of the United States as it did to British valor and strategic brilliance. The liberation of the Netherlands and the push into the Ruhr industrial heartland exemplified the operational problems Britain could not solve alone. The terrain was heavily fortified, rivers had been dammed or destroyed, and German forces had established complex defensive networks. British commanders, experienced in maneuver warfare, understood the objectives but were constrained by insufficient bridging equipment, armored support, and mechanized transport. American-produced Sherman tanks, bridge-laying vehicles, and engineering trucks provided the practical solutions necessary for the Allies to overcome these obstacles. Each technological and industrial innovation effectively removed a barrier that had previously dictated cautious and incremental advances, allowing rapid penetration into heavily defended territory. Air support, essential to maintaining momentum, also benefited from American innovation. Britain's early radar, fighter, and bomber systems were effective but limited in quantity. American production produced thousands of long-range aircraft, including fighters capable of escorting bombers deep into enemy territory and medium bombers optimized for tactical strikes. Integrated communications, improved navigational aids, and advanced ordnance allowed these aircraft to operate with precision, supporting ground offensives in real time. British commanders could plan operations assuming continuous air superiority, a capability that transformed operational calculations and solved the problem of coordinating complex combined arms maneuvers across multiple fronts. American contributions to logistics continued to redefine operational possibilities. Modular supply chains, prefabricated storage facilities, and standardized vehicles ensured that British forces had a continuous flow of fuel, ammunition, and provisions. Previously, planning had been dictated by limited resupply options and the fragility of supply lines. Now, forces could advance rapidly with confidence that operational momentum would not be interrupted. The integration of American innovation into British logistical systems solved one of the most persistent and constraining problems in modern warfare: sustaining large-scale operations over extended distances under enemy pressure. Armored combat in urban and industrial terrain posed challenges Britain could not have met alone. Sherman tanks and specialized variants provided mobility, firepower, and repairability, enabling British forces to engage in urban combat, river crossings, and fortified positions with confidence. American-designed engineering vehicles removed obstacles, cleared mines, and facilitated river crossings, solving tactical problems that had previously resulted in heavy casualties or operational pauses. In combination with precise artillery and air support, these innovations allowed British forces to maintain offensive pressure, turning theoretically formidable defenses into manageable challenges. Intelligence and communications, integrated with American-produced systems, allowed unprecedented operational coordination. Radios, direction-finding equipment, and portable encryption devices enabled commanders to synchronize movements across armored, infantry, and airborne units. Reconnaissance data could be relayed instantly, and orders adjusted in real time to respond to enemy movements. Britain's strategic foresight could now be implemented without delay, solving the long-standing problem of command and control across extended, dynamic battlefields where miscommunication could prove fatal. Medical and human-centered innovation continued to sustain operations and morale. Portable field hospitals, American antibiotics, and rapid evacuation systems allowed wounded soldiers to survive injuries that might have previously been fatal. This human resilience ensured that operational strength remained high even during the most intense battles, turning previously unsustainable casualty rates into manageable operational conditions. American innovation, in essence, solved the human dimension of warfare, ensuring that strategy, tactics, and production were aligned with the preservation and effectiveness of fighting forces. Environmental challenges, from winter flooding to ruined infrastructure, were mitigated by American engineering. Prefabricated bridges, portable road panels, and amphibious vehicles allowed British and Allied forces to maintain momentum despite obstacles that had historically delayed campaigns. Sherman tanks equipped with specialized tools for mine clearance and rubble navigation solved practical problems on the battlefield, allowing operations to proceed on schedule and preventing the disruption of strategic objectives. The practical application of American ingenuity ensured that environmental constraints no longer dictated operational tempo. By mid-1945, as Allied forces entered Germany's industrial heartland, it was evident that American innovation had not only solved the operational and logistical problems Britain could not address alone, but had redefined the very nature of modern warfare. The combination of industrial capacity, technological ingenuity, and applied engineering created a force multiplier, transforming British strategy from constrained planning into unstoppable operational execution. The liberation of occupied Europe and the defeat of Germany were as much a testament to transatlantic innovation as they were to courage, strategy, and determination. The final months of the European campaign underscored the indispensable role of American innovation in ensuring sustained Allied momentum. British forces, seasoned and courageous, were pushing through territories devastated by retreating German armies, yet the scale of operations demanded logistical, technological, and engineering support beyond Britain's capacity. American trucks, jeeps, and supply vehicles allowed armored divisions and infantry brigades to move with remarkable speed, while modular bridges and portable engineering equipment enabled forces to traverse rivers, rubble-strewn roads, and destroyed infrastructure without delay. Each technological solution addressed a tangible operational problem, turning logistical bottlenecks into seamless avenues of advance and ensuring that momentum was never lost. Air support remained a decisive factor, with American long-range bombers and fighters complementing British aircraft in joint operations. Strategic and tactical bombing campaigns disrupted German supply lines, communications, and troop concentrations, while fighter escorts ensured Allied bombers could operate with minimal losses. Navigation aids, radar systems, and precision ordnance produced in American factories allowed for effective targeting even under adverse weather conditions, a problem that Britain had struggled to solve on its own. This combination of scale, technology, and integration ensured that the British advance was sustained and supported by unmatched aerial dominance. Armored units continued to benefit from American design philosophy. Sherman tanks, reinforced and modular, could be repaired quickly in the field and adapted for specific tasks such as mine clearing, river crossing, or urban combat. Specialized engineering vehicles, produced en masse, addressed obstacles that had previously immobilized British forces, allowing momentum to be maintained during high-intensity operations. The integration of mobility, firepower, and engineering ingenuity solved the problem of operational continuity, which had historically constrained campaigns to cautious, incremental advances. American innovation extended into the realm of materials and fuel as well. High-octane aviation fuel, synthetic rubber, corrosion-resistant metals, and specialized lubricants ensured that vehicles, artillery, and aircraft could operate reliably in extreme weather, urban environments, and devastated terrain. British commanders no longer needed to factor material fragility into operational plans. Machines performed predictably and consistently, allowing strategic calculations to focus on enemy movements and objectives rather than equipment limitations. This technical reliability directly solved operational problems that had once dictated caution and limited initiative. Communications and intelligence continued to define operational efficiency. British commanders, operating across extended front lines and multinational formations, relied on American-produced radios, encryption devices, and direction-finding equipment to coordinate movements in real time. Reconnaissance data, intelligence reports, and logistical updates flowed seamlessly, enabling rapid adjustments to operational plans. Where miscommunication or delayed information might previously have led to costly errors, American innovation ensured that command decisions could be executed precisely and effectively, solving the persistent problem of coordination across dynamic, multi-theater battlefields. Medical innovations provided critical support to the fighting force. Portable surgical units, antibiotics, and rapid evacuation systems produced in American factories ensured that wounded soldiers survived injuries that would have previously been fatal. This preserved manpower and maintained morale across forward positions, allowing campaigns to continue at high intensity without the disruption of catastrophic casualty rates. In this sense, American ingenuity directly impacted both the physical and psychological resilience of British forces, addressing challenges that went beyond machinery and logistics to sustain the human element of warfare. Engineering solutions allowed the Allies to overcome both natural and man-made obstacles. Prefabricated bridges, modular road panels, and specialized vehicles enabled rapid river crossings, minefield clearing, and urban operations, turning logistical nightmares into manageable operations. Each advance showcased the practical application of American innovation, solving battlefield problems that had previously slowed or stalled British offensives. The integration of engineering, mobility, and tactical skill ensured that operations proceeded on schedule and with maximum efficiency, reinforcing the operational advantage gained through industrial scale. By May 1945, as British and Allied forces entered the heart of Germany, it was undeniable that American innovation had solved problems Britain alone could never have overcome. From production and logistics to engineering, medicine, and technology, every domain where limitations had once constrained strategy had been transformed through transatlantic collaboration. The victory in Europe was therefore not merely a triumph of courage, planning, or experience. It was a testament to the power of innovation applied at scale, demonstrating that the combined genius of Britain and America could overcome challenges that neither could address alone, reshaping the conduct of modern warfare forever. The push into southern Germany and the Alps in early 1945 presented unique operational challenges. Rugged terrain, narrow mountain passes, and entrenched enemy positions required mobility, engineering, and firepower on a scale Britain could not provide alone. American-produced Sherman tanks, modular engineering vehicles, and specialized transport trucks enabled British divisions to maneuver through terrain that had previously been considered impassable. Bridges could be quickly replaced, roads cleared, and artillery emplacements bypassed or neutralized. Each solution, born of American industrial capacity and ingenuity, transformed the operational landscape, allowing British commanders to maintain initiative where logistical and technical obstacles had once dictated caution. Air support remained critical in these late stages of the war. Britain's early Air Force designs were effective in tactical engagements, but limited in endurance and range. American long-range bombers and escort fighters filled this gap, allowing sustained attacks on German supply lines, communication hubs, and retreating formations. Precision bombing, aided by radar-guided navigation and advanced ordnance produced in American factories, neutralized enemy positions that might have otherwise delayed British advances. The combination of British planning and American technological capacity turned previously intractable problems, extended operational reach, and continuous air support into manageable advantages that accelerated the collapse of enemy resistance. Medical and logistical innovations continued to sustain the fighting force under extreme conditions. Portable surgical units, antibiotics, and rapid evacuation systems, all produced in America, allowed British forces to maintain operational strength even in high-intensity combat. Fuel, ammunition, and food, delivered through American-designed supply chains and standardized vehicles, ensured that forward units were never immobilized by shortages. These innovations directly addressed the persistent problems of sustaining manpower and operational tempo, turning challenges that had previously slowed campaigns into predictable, solvable components of warfare. The integration of engineering capabilities allowed the Allies to overcome both natural and man-made obstacles with remarkable efficiency. Bailey bridges, portable road panels, and amphibious vehicles enabled rapid river crossings and the bypassing of mined or destroyed roads. Specialized Sherman variants cleared mines, flamethrowers neutralized fortifications, and modular equipment allowed repair and replacement in the field. American ingenuity solved problems that had once limited British strategy, transforming terrain and obstacles from barriers into manageable variables in operational planning. Communications and intelligence networks, underpinned by American-produced radios and encryption devices, ensured coordinated operations across multinational forces. British commanders could relay orders, receive reconnaissance updates, and adjust tactical plans in real time. The integration of this technology solved the persistent problem of operational coordination in dynamic and fragmented theaters of war, enabling swift exploitation of breakthroughs and rapid response to enemy maneuvers. American innovation bridged the gap between strategy and execution, transforming conceptual planning into real-time battlefield effectiveness. Armored warfare, bolstered by American design and mass production, provided the operational backbone for late-war offensives. Sherman tanks, with reliable engines, modular components, and specialized variants, allowed British forces to maintain continuous pressure on German forces, regardless of terrain or fortifications. Where Britain had struggled with mechanical fragility or insufficient production, American innovation ensured operational continuity, giving commanders the freedom to pursue ambitious objectives without fear of equipment failure. Each tank in the field represented a solution to a series of complex tactical and logistical problems, turning previously constrained planning into decisive action. The psychological and morale impact of American innovation was as profound as its practical effect. British troops, seeing reliable vehicles, uninterrupted supplies, and effective medical care, fought with confidence and resilience. The knowledge that their equipment, support, and survival depended on a robust and dependable industrial network allowed soldiers to focus on strategy and execution rather than scarcity and improvisation. This reliability solved the intangible problem of sustaining morale and initiative under the extreme stress of prolonged combat, demonstrating that innovation affects both material and human dimensions of warfare. By spring 1945, the cumulative effect of American ingenuity and industrial might had solved the operational, logistical, and technological problems that had constrained Britain throughout the war. Rivers were crossed, cities liberated, and enemy forces systematically dismantled. Britain's strategic vision, tactical expertise, and courage were amplified to unprecedented levels by American support, illustrating that victory in Europe had been achieved not only through valor, but through a transatlantic partnership and innovation that addressed problems at every scale, from battlefield mechanics to human resilience, ensuring that the Allies could fight and win decisively. As the Allies advanced into the heart of Germany, the industrial, logistical, and technological contributions of the United States became ever more apparent. The destruction of infrastructure, the presence of fortifications, and the chaos of retreating German forces would have slowed even the most capable armies. Yet American innovations, prefabricated bridges, modular road panels, standardized supply convoys, and specialized engineering vehicles, ensured that momentum could be maintained. British forces could now move at a tempo that defied historical limitations, overcoming natural and artificial obstacles with unprecedented speed. Each operational advance was a demonstration of how American industrial problem-solving had converted challenges into solvable tasks. Air operations continued to underscore the scale of American impact. Long-range bombers, precision-guided ordnance, and durable aircraft designed and produced in the United States enabled sustained aerial dominance. British ground units could advance with the assurance of continuous close air support, while strategic bombing disrupted German logistics, troop concentrations, and communication networks. Problems that might have limited British operational reach in previous campaigns, range, endurance, and payload, were solved through American innovation, allowing strategy to translate seamlessly into decisive action. Armored forces maintained continuous pressure thanks to American engineering and mass production. Sherman tanks, enhanced with modular components, reliable engines, and specialized variants, allowed British units to engage enemy forces across diverse terrains, from cities to river crossings to snow-covered passes. The logistical capability to repair, replace, and sustain these armored units directly solved the problem of operational continuity, turning mechanical reliability into a strategic advantage. American design provided the practical tools to convert tactical intent into battlefield success. Medical and human-centered innovations continued to support sustained operations. Field hospitals, portable surgical units, and antibiotics produced in America ensured that soldiers could recover from injuries and return to duty. This mitigated attrition, maintained manpower, and allowed commanders to plan ambitious operations without the constant concern of replacement shortages. American innovation addressed not only the technical and logistical aspects of warfare, but also the human dimension, solving the problem of maintaining an effective fighting force under extreme stress. Communications and intelligence remained critical in coordinating multi-front operations. American-produced radios, encryption devices, and direction-finding equipment allowed British commanders to issue orders, receive reconnaissance, and adjust plans instantaneously. The integration of these systems ensured that strategic and tactical initiatives could be implemented effectively, solving the persistent problem of real-time command across fragmented and dynamic battlefields. American innovation bridged gaps that would otherwise have limited operational effectiveness. Engineering solutions facilitated rapid river crossings, cleared mined roads, and neutralized urban fortifications, turning previously insurmountable obstacles into manageable challenges. Bailey bridges, portable roadways, and specialized vehicles allowed forces to advance continuously, even in the face of environmental and man-made barriers. American ingenuity in this domain directly solved problems that had historically dictated the pace and scope of operations, transforming logistics and engineering from limiting factors into force multipliers. The psychological effect of dependable technology, logistics, and medical support reinforced operational success. Soldiers knew that their equipment would perform, their supplies would arrive, and their injuries could be treated efficiently. This assurance enabled British forces to act decisively and sustain high-intensity operations. American innovation, therefore, solved both material and intangible problems, ensuring that operational tempo, morale, and confidence were maintained under extreme wartime conditions. By the end of the European campaign, it was evident that American innovation had been indispensable in solving problems Britain could not. From industrial production to logistics, engineering, medicine, armored warfare, air support, and communication systems, American ingenuity enabled British strategy to be executed at a scale and efficiency previously unimaginable. The transatlantic partnership had transformed theoretical plans into operational reality, demonstrating that modern warfare depended not only on courage and planning, but on the practical capacity to implement solutions across every dimension of combat. The fall of Berlin and the final surrender of Germany in May 1945 marked not only the end of a brutal conflict, but the culmination of a transatlantic collaboration that had solved the problems Britain could not address alone. Britain had conceived strategy, developed tactics, and fought with extraordinary bravery, but it was American industrial capacity, technological innovation, and logistical genius that allowed those plans to be executed at scale. Tanks, aircraft, engineering vehicles, supply convoys, medical units, and communication systems, all produced and refined in the United States, ensured that British forces could operate without the constraints that had hindered previous campaigns. The victory was a testament to the marriage of vision and capacity, courage and innovation. The liberation of Europe showcased the transformative power of American industrial and technological support. Infrastructure, fortifications, and natural barriers that might have stalled operations were overcome through engineering ingenuity. Armored divisions moved rapidly, infantry advances were supported by relentless air power, and supply lines remained uninterrupted despite the destruction left by retreating German forces. Where Britain had once faced limitations in mobility, firepower, and logistical sustainment, American innovation provided solutions that converted constraints into operational advantages, enabling decisive action across multiple theaters simultaneously. Medical and human-centered innovations played a decisive role in sustaining the Allied advance. Portable field hospitals, surgical units, and mass-produced antibiotics ensured that casualties could be treated and returned to duty, preserving manpower and morale. Soldiers fought not only with courage, but with the confidence that their survival and effectiveness were supported by a reliable system of care. American ingenuity solved the practical and human problems of sustaining a fighting force under extreme conditions, reinforcing operational and strategic success in ways Britain could not have achieved alone. The integration of communication and intelligence systems further exemplified the transatlantic partnership. British operational foresight could be executed in real time thanks to American-produced radios, encryption devices, and reconnaissance technology. Rapid relay of orders, coordination between land, sea, and air units, and continuous updates on enemy movements ensured that British strategy could be implemented with precision and reliability. This solved a problem of command and control that had long constrained large-scale operations, allowing decisive coordination across vast, complex battlefields. Armored warfare, logistics, and engineering reflected the practical application of American innovation in solving tactical and operational challenges. Sherman tanks, modular vehicles, prefabricated bridges, and portable roads enabled rapid advances, continuous operational tempo, and adaptability across varied terrains. Mines, destroyed infrastructure, and fortified positions, which had historically dictated cautious strategy, were neutralized by the integration of technology, mass production, and design ingenuity. American solutions allowed British forces to convert obstacles into manageable variables, amplifying strategic effectiveness and operational reach. Air power, produced at a scale unimaginable in Britain alone, sustained the advance and disrupted enemy resistance. Precision bombing, long-range support, and continuous fighter cover allowed the Allies to maintain initiative and pressure on retreating German forces. American innovation solved the twin problems of scale and reliability, ensuring that air support could be both pervasive and precise, directly enabling operational objectives that would have been unattainable for Britain alone. The psychological impact of reliable equipment, continuous supplies, and advanced medical support cannot be overstated. British troops fought with confidence, knowing that their ingenuity and courage were backed by an industrial and technological powerhouse. Morale, cohesion, and resilience were maintained even in the most intense battles, solving the intangible but critical problem of sustaining an effective fighting force under extreme stress. American innovation, therefore, addressed the full spectrum of operational challenges: material, tactical, logistical, and human. In the end, victory in Europe was as much a triumph of innovation and industrial capacity as it was of strategy, courage, and experience. Problems that had constrained Britain throughout the war, from logistical bottlenecks to equipment limitations, from battlefield engineering challenges to medical scarcity, had been systematically solved through American ingenuity. The collaboration demonstrated that modern warfare depended not only on valor and tactical skill, but on the ability to implement solutions at scale, transforming theoretical strategy into decisive operational reality. The legacy of this transatlantic partnership endures, illustrating how innovation can overcome even the most formidable obstacles in war.